we saw that we need to be careful when we are studying them. Why do we need a special technique when we are analyzing this type of survey? What I have to say two things before we go forward. I always send the PowerPoint presentation after the talk. You don't have to copy. I'm more interested that you pay attention and interrupt me and ask questions every time, because I understand we will be talking about concept that is not common to you guys. I probably wash out of them and talking about them. If you feel you have any question, you need clarification, stop me and we can talk. Make that a conversation between you and I about the topic. Then, in all in our statistical course, we use POC mean, we will POC Berg to do regression analysis. All these procedure, all the technique they use, they assume that the element are independent from each other. The observation are independent from each other. That means they assume that the data was collected using simple random sampling. That we will define this term later on. Then all the technique that we know, we use in the statistical software. If you use SAS, you use SPSS and Stata, they're all based on the observation are independent, the observation are drawn from a sample that was collected using random sampling. But that is not the case for this complex survey that I call them, the big national survey. They are complex survey. If we analyze them this way, we will get into incorrect conclusion, because we will underestimate the variance, we will underestimate the standard error. Then we need special technique to analyze this complex survey. When I say complex survey, those are the survey that we have these three elements highlighted here. They are stratified, the cluster, and they use weight. These three elements and the sampling, we have different effects on the estimation of the variance. And we will know that we need to control for them whenever we're doing the statistical analysis. The one concept is the concept of equal probability of selection. This is the gold standard. This is what we're looking at. We're looking for. We're looking, if we have a sample, everybody should have equal probability of being selected in our sample. That will be what we call a sample random sampling, that each element has an independent and equal chance of being selected to the sample. It's that I have a list of the element and I select 10% of the element randomly. Each of the element on the list, we have equal probability of being selected. This is why it's very easy to do simple random sampling. That say that the list is very small. The homogeneous, if there are things, I can have access to it. If I want to do a survey of UK students, I can get access to the email of all the students, to the list of the students, to send them out the survey. But it's not the same if I want to do a survey, a nationwide survey. I don't have a list of the people. I don't have the address to send them the survey. Then doing simple random sampling, if you don't have a very, very small group, then it's very expensive. It will be not practical. If I'm doing a survey of the US and I start randomly selecting people, I will get one person selected in Alaska and probably 20 persons selected in California. I have to go to Alaska to interview one person who send him. Then that make it difficult. If we use sample random sampling for this last survey also, we will lose the opportunity of representing the minority group. We should have some group that we are interested in that we need not be included in our sample. If we select people from a list, then we have to be careful in using an alternative that is the complex sample. We will use these three elements that I mentioned. We will use stratification, clustering, and weighting that will help us to improve the efficiency, the precision of the estimate, and that will reduce costs. And also I will be able to do subgroup analysis. Let's say if I'm interested in doing a nationwide survey, I probably need to oversample Native American, oversample African American, so that they are well represented on my sample. And be able to do analysis taking into account ethnicity. Things like. Or
oversample some subgroups. Do we need to get the same number of the observations from this subgroup as the other bigger group?
Yes, that will depend. I will answer your question later in the presentation. There is a slide that is about that. I will remind. Yeah, that's a good question. I have a slide when we're talking about stratification, when I go over how you can stratify people and what this is. Your question is about disproportionate stratification. How do you know how to stratify the oversample? But whenever, this is very important, whenever we have these three elements present in our complex sample, then the observations are no longer independent, because they are no longer independent. That doesn't mean we don't have ways of getting unbiased estimate. We still can get unbiased estimate if we control for this, the effect. We call it design effect. If we control for the effect of these three elements in the sample, when doing the analysis, we still be able to get unbiased estimate. You guys are familiar with this. This is part of our statistical course. If we have a sample, we assume the sample was drawn using sample random sampling. The mean is only the sum of the outcome for each element divided by the number of observations that we have in our sample. And the variance is the difference between each outcome of each observation and the mean squared divided by the number of observations minus 1. We know all our program will do that for us. We know how to calculate the sample this way. But when we have complex sample, then, as I mentioned, we have to take into account what is in the design of the complex sample. The design means the use of the three elements. All three elements might be in the sample, or combination of them. Only one might be, it will be only a stratified sample, but it should be a stratified cluster sample, or any combination between the three of them. We have to take that into account. Then we compare what will be the variance with the sample random sampling with the variance in the complex sample. And we expect the difference between them will be the design effect. We call it the design effect. The square root of the design effect is what we call an inflation factor that we expect if we use complex sample, the standard error will be inflated by the value of the square root of the design effect. They, whenever we use complex sample, we expect greater standard error, greater values. Then we need to take take that into consideration. Then the square root, the depth, that is the square root of the design effect, can have these three values. It can be equal to 1. If it's equal to 1, we say there is no effect on the standard error. The complex sample will be equivalent to using sample random sampling. We don't have an effect on the standard error. If it's greater than 1, we have an inflation of the standard error. If it's lower than 1, then my complex sample will have better efficiency in terms of reducing the standard error compared to the sample random sampling. All of these will be included. This is an example of two surveys. We take the mean of the age between all of them, and we find that we get the standard error using complex sample. These are the depth. If you can see the depth are greater than 1, that means this complex sample inflate the variance compared to sample random sample. It's like the comparison when we do ordinary least square regression. It's like the basic of all regression. We study ordinary least square, and all of the regression that we do, we compare them to least square. We take the log, we transform the variable. If we're doing logic, we take the logic of the